Ready to complete the boutique suggestions exercise and master Elixir's powerful list comprehensions? This video shows how to use the for keyword with generators and filters to quickly generate and refine outfit combinations. Let's dive in and write some clean declarative code. Grab your starter file and follow along. Howdy, I'm Kevin. In these videos, I pair my development experience with AI tools to help present comprehensive exorcism solutions. I prompt Copilot to add documentation and provide a starting solution. The real learning begins when we diagnose its output and build clean, idiomatic Elixir solutions together. I'll include segments of NotebookLM videos and courses to introduce concepts. Here's how NotebookLM introduces comprehensions.
List comprehensions. They give you a declarative way to build new lists from existing ones, making your code incredibly powerful and, most importantly, readable. Okay, so what exactly is a list comprehension? Well, think of it as a way to describe the list you want to end up with, instead of having to write out every single step to create it. You just tell Elixir, hey, start with this data, apply these rules, and give me back a new list that looks like this.
I'm always refining my use of AI as a study partner. Do you know of a favorite AI learning tool I should try? Tell me about it in the comments.
So here's our first challenge. We've got a list of tops, we've got a list of bottoms. How do we efficiently generate every single possible pairing? Okay, here's our starting data. Super simple. A list called tops and a list called bottoms. As you can see, each item inside is just a map with a name. Our goal is to create every possible combination of one top and one bottom. And the solution? Well, it's that exact multiple generator pattern we just looked at. We just say, for each top in the tops list and for each bottom in the bottoms list, create a new tuple containing that top and bottom. And just like that, we have a list of all possible outfits, which sets us up perfectly for our next step.
Copilot generated some perfectly good code to solve this exercise. But as all three steps of the exercise augment a single function, I've removed some of it so we can focus on it step by step. So here's what the solution would be after instruction number 1. For each top in tops, take each bottom in bottom and create a tuple with the top and the bottom. And this ends up being a list of these tuples. I found it a little bit hard when looking at the README or the instructions to recognize that the outer parentheses here were the tuple of the top and the bottom, and what's inside here is the map, which is the top data and the bottom data. So that's what we're after. We're after this. Now, one comment I will make is that it's more common for options keywords to be ops. And as we're not using it right now, we would ignore it.
Okay, let's make our suggestion engine a bit smarter. How can we teach it to automatically spot and throw out outfits that clash, say when the top and the bottom have the same base color? To make this happen, we need a little more information. So we're going to add a base color field to each of our clothing items. This new piece of data is exactly what we need to compare the colors of the top and bottom. And check out how simple the solution is. We just add a filter condition, top.baseColor not equal to bottom.baseColor, right after our generators. This single line of code adds a really powerful rule to our pipeline, making sure only the non-clashing outfits make it into our final list. It's so clean.
All right, to only keep those for which the base colors don't match, we can add a filter. Now that we've got a reference to a top and a bottom variable, we can add where we want the top base color to be not equal to the bottom base color. And so then when it's iterating through these combinations, so long as this is true, this filter condition is true, it will keep them. Otherwise, it will reject them and we won't get this tuple and an entry in the overall list. Elixir's list comprehensions make the intent of generating and filtering lists declarative and immediately clear. The for syntax lays out the generators and filter conditions in a single, easy-to-read block. This clarity reduces cognitive load and allows any developer to quickly understand the list's origin and constraints.
So for our final task, we need to think about the customer's budget. We have to figure out the total price of each outfit and then only suggest the ones that fall within their specified price range. And you probably guessed it. To do this, we're going to add another field to each item, : price. We'll also have an external variable. We'll call it max_price that represents whatever the customer's budget is. And here it is, the final solution. We just tack on another filter. This one checks if the combined price of the top and the bottom is less than or equal to that max price. This really shows how you can just stack multiple filters together to build a powerful, multi-stage data processing pipeline inside a single, easy-to-read comprehension.
Finally, to limit the combinations based on their total price, we need to get the maximum price that's passed in the options. You may remember from a few episodes ago, we could use the access mechanism to get the value out of a keyword list. And if this were to be null, we could give it a default value like this. I think the better way to do it is to use the keyword get option. It has a specific optional variable for what we want the default to be. And then we could use that as a filter by saying, so long as the top price plus the bottom price is less than that max price. Did you know Elixir comprehensions aren't limited to lists? You can use them with any enumerable structure like maps or ranges, making them an incredibly versatile tool for data manipulation, far beyond what you might expect from a basic list feature.
So, to sum it all up, we learned how to use multiple generators to create all possible combinations. Then, we saw how easy it is to just layer on simple filters to get rid of the data we don't want. And we even used external variables to make those filters dynamic. This whole approach lets you build these beautifully clean declarative pipelines, and that is the hallmark of idiomatic Elixir.
Here's what the solution might look like if you were to try and do it without 4 comprehensions and just used Enum modules. So I said, all right, for all the tops for each top and tops, create a map for each bottom and bottoms. So this produces a list. So then what we've got here is a list of lists that have to be flattened out. And it creates every combination there would be before it then rejects values. Now there are other Enum sorts of approaches, but let's go for this blunt, straightforward way. So then if we look at benchy benchmarking of the Enum version versus the comprehension version, what we can see is that the Enum version is 2.5 times slower and uses 2.5 times more memory. And this was off of the tops and bottoms each having 1,000 things in them. So you could imagine if you were Amazon that this would certainly add up quickly. Be sure to like this video if it generated the perfect combination of clarity and code. Subscribe for more products like this. Dive into the playlist to build your Elixir expertise, one powerful function at a time. See you there.